Hello everybody, Root Beer here, and thank you for joining me. We're looking at question 17 in this video. The digits 2, 4, 6, and 8 are each used once to create two two-digit numbers. What is the smallest possible difference between the two two-digit numbers? Okay, so we want the smallest possible difference here. How would you get the smallest possible difference? Well, you would need numbers that are particularly close, right? We want our numbers to be as close as possible. Okay? Now, there's lots of two-digit numbers you can make with these, and you could actually start listing them all out in order, okay? And taking the difference. Now, the smallest answer isn't going to be 2 because I can't form 26 and 28 using 2, 4, 6, and 8 with each digit used only once. I've used the 2 twice. Okay? But this is certainly an option. Okay? It doesn't take too long to write these all out. Okay? 82, 84, and 86. And you could start asking, okay, well, if I want numbers that are close together and using my 2, 4, 6, and 8, we could start trying to find things. Now, if I use my 6 and my 8 here in one number, I have to use the 2 and the 4. Which one's closest to that? Well, 42. And you can play around with this with them all listed out, and it won't take too much difficulty to find it. You know, for example, you can see quite nicely 48 and 62 are really, really close together. And then you say, 62 and 48. What's the difference there? Well, 14. So 14, you work out, it happens to be the closest you can possibly get. But, you know, that works for this question because there's only so many ways we can write them out. Okay, they happen to be listed out. There's only 12 different numbers. So, yeah, you can guess and check your way to success and get the answer of 14, which is B, which is the second smallest of the presented answers. But is there a smarter way to do this? Well, yeah, let's think about this. If I want my small number, which I'll represent with these two dashes, we're going to fill it in, and my large number to be close, I really need their tens digits to be close. You know, if you have wildly different tens digits but really close units digits, your numbers are still going to be far apart. Okay? But if you have particularly close tens digits and the units digits wildly apart, the close tens digits are still going to make up quite a lot of your difference. So with that in mind, we might start thinking, okay, maybe I want a 2 and a 4 here. Because those are pretty close. Or maybe I should have 4, my lowest one in the 40s, and my next one in the 60s. Close tens digits make my number closer. Or maybe I need to do 6 and 8. Okay? And even this reasoning here can narrow things down a little bit for me. Now, if I've got the 6 and the 8, well, what's left over? I need to use the 4 and the 2. Should the 4 go over here and the 2 go over here? Well, no, because you're going to have a bigger difference than you would if you put the 4 over here and the 2 over here. And you can say, all right, well, then what's that difference? And you work it out. And you'll see it's a difference of 18. Okay? Or you could have the 2 and the 4. And then you'd put the 8 here and the 6 here, because that would get them as close as possible. Also has a difference of 18. Okay? But we've narrowed it down to only 3 things we have to guess and check. So if we did 4 and 6, we'd want 8 and 2 like this. Okay? And the reason this works best is the numbers that are left over can actually sort of be closer together than the 8 and the 6 can be. And so you get a difference of 14. So you get B with a little less guess and check and a little more thought. And it's always a great idea when you're doing these questions to have a nice logical approach, think your way through problems, don't guess your way to success. Because, yeah, it might work on the Gauss paper and maybe on next year's Pascal paper, but by the time you're writing the important papers, the papers that people are going to pay attention to and pay attention to you if you do well, guessing is not going to be a viable strategy. There will just be too much stuff. Okay? Maybe, in a harder question, they would say you've got the numbers 1, 2, 3, 4, 6, 7, 8, 9, and I want the closest 4-digit numbers possible. You're not going to guess your way to an answer that time. No. Okay? So you do want to learn this reasoning of, okay, tens should be close, and then that narrows it down. So which of these other numbers or other pairings of numbers work best? Okay? So there we go. Nice little question. That was question number 17. Up next, question number 18.